Alright, welcome back. Continuing on with the Skymaster 1/6 scale F-18 build. Still just working on the one wing. It's a lot of work because I got to fix a lot of things that I'm finding. So that's what this video is kind of about, just kind of show you what I've had to do so far to kind of help you out. Plus I'm going to show you the individual components for each servo. You know, like the aileron, the flap, and the leading edge flap. Had to change a couple little things just because of their mess up, and I don't like some of the hardware they gave me. So I'm going to use a couple different things, but I mean you can use the stock if you want. So we'll get to that. So let me grab the. Alright, so turn this around. Alright, so yesterday I was working on trailing edge flap. It's in there. I put the arm on it. I'm using these. I got a bunch. Ooh, excuse the mess. Everything turns into a mess, but I got these big Futaba arms. They're pretty nice because they got the dual clamp and they're threaded, so they're real beefy. I got some SWBs as well, but they're always too long. So I'm using those, trying to use those on, where I can on this build. I think these were actually car arms I got from Futaba. Anyways, they're really nice. They're heavy duty, so they're real thick in this area. So if you got a threaded screw or something, so if you don't have a threaded screw, they're kind of like you're gonna put a lock nut on the back of it or something. These are kind of thick, but you can always grind that off and just have that arm, which is probably what I'm going to do, just to keep them narrow. But anyway, so that one's in. I had to do the like I said, let me find, where's my drill, just use one of these little cutters to do the whole recess so the screws fit flush and don't hit the actual hatch. A lot of trimming to get these things in, but it's in and seated. Next thing will be is attaching the arm and connecting the control horn, which I'm going to do. And then I moved on to the aileron slash flap servo. Same arm, same deal. The L brackets with the flush fit screws. The problem I ran into here was when you put the servo in, it would, because it's such a thick portion of the wing, it actually started, it's sitting on the top part of the wing, and so when I tightened the screws down, it pushed down. You could see, like if you flip the wing over, you could see like the line of the servo pushing through on the bottom of the servo. So what I did was just put one washer underneath each screw area underneath the bracket to lift the servo up, so it gave it just enough clearance to where it didn't press down too much to make an indentation, and ultimately bulge the top of this cam. So the problem I ran into yesterday, I mentioned already, was the fact that where this guy would go kind of falls in line. But after getting so I'm going to recant my statement that this bracket was in wrong. So it's not in wrong, but the way they show doing it, so it kind of is, in my opinion. I think it should have been flipped over so the mounting points were here, so the servo arm would be over here, because the instructions they have, I swear, every kit they produce, it's different. Because I'm looking at the kind of instructions, which isn't really instructions, just a few pictures, and their arm goes right along this side, and there's no way I could get it. I mean, I could mount it on this side, but using their type of clevises that they give you these clevises, and then in the instruction manual that they give you, they don't even use these. They use what I end up using a lot of the times, just because of their bad geometry. I end up using a ball end, because it gives it a little bit of movement. So that's what I was doing here. So I'm going to use a ball end, and what the deal is, the reason why they want it close to this guy is because you got this thing that goes over and essentially covers it like that. So you can't have you could, but what they did is they just put it close enough so you're really you're having to cut out this area or this area next to the hinge, which I don't really like because that's just weakens it. But a lot of this that you're going to cut out, hopefully, well, no, you got to go into the back frame. But actually, you're really only going to cut this flaring, so you're not going to get into this back spar here. Down here, I don't know. I'll have to see. You may get into a little bit of that, but hopefully not. So what I'm going to do, and that's another thing I did, their rods are flimsy. I got some bunch of titanium rods, so I'm upgrading to a titanium rod because the way they did the hinging and the setup on this, it's kind of like a reverse mechanical advantage. So instead of the mechanical advantage helping the servo and, you know, helping prevent flutter, it's actually opposite. I mean, you're on the 0 point of the actual aileron, and you're up about an inch on the rod versus being further down towards the center and higher up on the control surface. That being said, I don't know, because of this hinge point being up here, if that really affects the servo, but I've already had one Skymaster jet that had a flutter issue, and I had to redo everything because it burned up 2 of these 500 ounce servos, or actually the 172s, and they're not cheap. So anyways, so I will probably, just based on this, probably be, and I was trying to get it perpendicular to the line here, so I was going to try to get it on this side, which is kind of what their picture showed anyways, because the picture showed it closer to this little fairing, you know, it showed it being on this side. So I may mount it, you know, the ball on this side just like this, so get it like that. Because I'm trying, so over here you're more of an angle towards that, see it, it's kind of an odd angle. If you move it over here, it's more perpendicular to the hinge line, so that's what I'm going for. So anyways, so a little mod, depending on how thick your servo is, you may have to put a little bit of lift underneath these mounts. And just remember, when you're cutting this stuff, this has got to go over all this, so kind of keep it as close as you can. And that was about it. These are the hinges that they give you that are going to glue in like this. So they have them coming straight out of the leading edge. That's why you have to cut so much out, because it goes down into the thing. I thought about maybe gluing them up a little bit, you know, just so it sits above the wing. I'll just have to kind of evaluate that. I need to make some drawings just to kind of see what kind of mechanical setup they got here. I can't picture it in my brain. Okay, and then a lot of cutting there too, to get it in there. And then I started on this guy. A lot of sanding to get these blocks where I can get this, and then this back area over here for the wire on the servo. But I got it cut out, and I wanted to show you guys how they're doing this leading edge flap. You can kind of see it here. Actually, I've got another one. This is what's glued into here. Based off the pictures, their picture shows it like this. Mine are like this, so I don't know. Looks like they glued them in backwards or upside down. I don't think it's going to be an issue on throw, but we'll see. So, because what they show is it like this, and then you lift the arm way up, and then you kind of tighten this little mechanism with the servo loose and everything, because it, you know, you take the rod out for this thing, and it allows you to bring it up more so you can tighten it. And you know, with this thing already on the servo, because if you tighten this down early, you can't get it in here when you're trying to get servo. So you have to leave this loose, the bearing loose, and you know, this just kind of like moves around. And if it was like this, you would obviously see how far more it would stick up, and then you just come in and tighten the screw down, and then you set everything down and then put your screws for the servo. So we'll see how that goes. But here's what they give you. This is kind of another thing I want to show you. They give you two bearings each for each side. One's an extra because you only end up using one. 4 washers and a 3mm with a 3mm lock nut. I changed these out because their 3mm screws were just a hair too thick, and I couldn't get them over the bearings. I didn't want to damage the bearings, so I had some titanium ones just like this that work nice. And a change that I did is, instead of using both bearings on top of each other to get the bearing over in, where it needs to sit in this race, I took one of these things, which is what you normally see. It's like an angled, here's one. It's like an angled piece that's flat on one side and angles up, and it's used on these ball ends type deal. So the taper end would go towards the ball, gives it like some standoff from the arm. So I just took an extra one that have a bunch of these. So I put it under there. It's kind of hard to see. So the little tapered piece, a washer, bearing, washer, and the lock nut I'm not going to use because it doesn't need it. I actually drilled and tapped my servo arm so I can actually tighten the screw down on the servo arm. The nut is just going to be kind of like an extra security, but the screw isn't long enough to get into the locking portion of the nut, so I'm just going to use these. Where'd they go? Pawls, tactical pawls. I got them somewhere. It's just a 3mm. Oh, right there in front of me. Just a little 3mm hex nut. I'll put some Loctite on it, because then I can get in with a pair of little wrench and tighten them down on the back side of the servo arm. So that's kind of like my mod for that. So this will be essentially on here like this, and you can kind of see how I've already got it set. You got to get the bearing adjusted where it sits right in that thing. Like I said, hopefully I can get this thing in here. See what I mean? It's kind of like I can't get it to lift up anymore, but if it was flipped over like it was supposed to be, it would be up higher. It allows for more clearance. See how it's like that versus being down? It hits lower. So mine are in like this. They should technically be like this, so it'll come up higher, and I could get this damn bearing in that groove and seat the servo and then tighten it all down. So hopefully I can figure this one out, because that's as high up as it'll go even with this thing loose. Like if it was sitting like this, you see how you got more area to clear and get up higher versus the way mine is. So we'll see. But that's what I'm working on now. Just wanted to show you guys this little way I did this. They said 10 millimeters, but with this is at like a little over 10 millimeters. I think it's like 15. Let's see here. It's about 15 well, a little less than 15 millimeters, about 12, 13 millimeters. So that's close enough. This groove is bigger than it needs to be, so you got a little bit of room for error. Because I don't have any damn servos with a 10 millimeter draw unless you use the plastic round things, and I'm not using those. So yeah, that's it. So let me finish working on this flap servo, and I will get back to you guys. So take it easy. Oops, where's my remote?